a vital role in the modernization of the civilization. It is everywhere and affects the everyday lives of our people. Although it is abstract, and one has to imbibe knowledge in mathematics, especially research point of view. And nowadays, applied mathematics is playing a vital role in the field of mathematics, which is very useful in the allied subjects of mathematics, especially in physics, chemistry, and even computer science, artificial intelligence, so on and so forth. And as you're aware that Ramanujan was born on 22nd December 1887 in Erode district of Tamil Nadu. And Ramanujan, he contributed a lot in number theory. He made a lot of wonders, especially in infinite series, mathematical analysis, and making formulae and equations. And he compiled, as we are aware, more than 3,900 mathematical results and equations. And his discoveries, namely Ramanujan prime number theory. As we are aware that Ramanujan prime and Ramanujan theta function inspired further research on the subject of number theory. And you might be knowing that Ramanujan was said to be the natural genius, though he had no formal education, but he made wonders, and he was very much impressed by his guru Harday. And he also made some combined work in number theory with Harday. And especially he had got so much mathematics. Actually, he was a natural genius. And uh, I want to give some glimpses of his history or birth history right from his beginning. And as I told that he was born in 1887 in Erode, which is located at Tamil Nadu. And his house is located at Kumbakonam, where the family had moved after his birth. Now it is now maintained as the Srinivas Ramanujan International Monument, and one can go and visit his place. And he was married to Janaki Ammal in 1909, and who was 9 years old at that time. So that was his married life. And he is recognized as one of the greatest mathematicians of his time. But Srinivasa Ramanujan had almost no formal training in mathematics. And what was the beauty of his mathematics knowledge? Nowadays, if we invent something or if we discover something, within no time it will be spreading in WhatsApp, in Google, in so many medias, and so on and so forth. And it took 100 years to recognize the talent of Ramanujan. Once upon a time, there was no any media. So whatever he has discovered, people could able to see only after more than 100 years. So had there been so much uh, communication system, we would have been very fortunate. But anyhow, so much research is going on nowadays to continue his research. And he was the second Indian to be inducted as a fellow of Royal Society, which is a fellowship of some of the world's most eminent scientists. And he is also follower of his and he compiled, as I told, around 3,900 results. Mostly these are identities and equations. He delivered some of the results as extempore. People, they are accepting results, but they could not prove as on today. As we aware, one place at Chennai, that is Ramanujan Maths and Science, a lot of research is going on in that place to know the future aspects of perfect number. Just I want to give what is a prime number. As we aware, a number which is divisible by 1 and itself, that is known to be prime. And that prime number can be divided into, as per his theory, even perfect. And one more thing I want to give, what is a perfect number? A number is said to be perfect if it is equal to sum of its proper divisors. And I can tell that 6 may become a perfect number. What are the proper divisors of 6? 1, 2, 3, and I am excluding 6. Sum of 1 plus 2 plus 3 is becoming 6. So that is that can be taken as a perfect number. If it is equal to sum of its proper divisors, you should not actually include that number. And after 6, 28 can become a perfect number. What are the proper divisors of 28? 1, 2, and then 4, 7, and then 14, and you should not include. So likewise, each and every student cannot become perfect. So as numbers, all numbers cannot be regarded as a perfect number. Whichever it is satisfying that axiom, that can be regarded as a perfect number. So after 6, 28, so much gap will be there. Something like 496 or 498 will be there as per my remembrance. And some research is going on to investigate about perfect numbers, and whatever the perfect numbers now they are available, they are only even perfect numbers. So far no odd perfect number is seen. Some research is going on in this number theory. So after that one can have some more light or some more knowledge about what is abundant number and what is deficient number. So a number is said to be abundant number if sum of its divisors is greater than that number. Similarly, what is deficient number? A number is said to be deficient number if the sum of the divisors is less than that particular number. So likewise, so many types of numbers will be available. What is the FERMAT number? So all these, the interest of research is to generate prime numbers. And we can also see the beauty of FERMAT prime number. A number is of the form 2 power n plus 1. That is known as a FERMAT prime. As Nagesar rightly, he kept this name. And I wish all the best, Nagesar, as you have rightly kept FERMAT. So FERMAT theorem is very famous in number theory and even FERMAT primes. So a lot of research is going on to investigate about prime numbers. And I want to give some more methods or platforms to create prime numbers. One such theory is Siva Ferosthanis. If you want to generate number of primes between 1 to 100, we just take numbers within a table and then start with the first prime 2 and then truncate the multiples of 2, and you go on cutting till you get 2, 4, 6, 8 up to 100, and again start with 3 and cut down its multiples. So do not touch actually 3. And what are multiples of 3? 6, 9, 12, 15. Likewise, if something has been cut already, you don't bother, and if at all it is fresh, then only cut. Otherwise we need not bother. Likewise, what can be the last number before 100, which is a multiple of 3? That is only 99. So go on truncating like that. Similarly, what is next prime? 5. Do not touch it, keep away, and then cut down its multiples, say 10, 15, 20, and last number perhaps that is 100, that has been already cut down by 2. Likewise, and cut down multiples of 7. So and whatever the numbers they are left after truncating all the numbers, they can be observed as prime numbers. So we will be observing that one is neither prime nor composite. We can keep it away. Then starting with 2, we are getting 2, 3, 5, 7. Likewise, we will be seeing the table. That is one aspect of generating a prime number. And one more conjecture is there to generate prime number, that is known as Goldbach conjecture. How to generate Goldbach conjecture? So every even number that can be expressed as a sum of 2 prime numbers. For example, I am taking some 6. 6 is an even number. Is it possible to express 6 as a sum of 2 prime numbers? Yes, you can express as 3 plus 3. They may be repeated, no problem. Similarly, one more example. Suppose if I give one even number 10. 10 can be expressed as a sum of 7 plus 3 or 5 plus 5. This is one conjecture. This is known as Goldbach conjecture. So many theories have been developed to generate prime numbers. The theory of the beauty of number theory lies in investigating about prime numbers only. So as I told, one of such methods is generating primes by Siva Ferosthanis, and then we can also use square root method. Square root method means we take some number, find its square root floor function. For example, if I want to get root 97 or 97, whether it is a prime or not. So how can I say that 97 prime or not? Just I will find root 97. You know, that is certainly lies between 9 and 10. 9 and 10. Why? Because that is floor function of 9 is greatest integer, not greater than, that will become only 9. And the theory says that pick up all the primes which are less than 9. So what are the primes which are less than 9? We'll get 2, 3, and then 5, 6. See that 97, whether it is divisible by all these numbers or not. If at all it is not divisible by any one of these numbers, that can be regarded as a prime. Otherwise, it cannot be called as a prime number. Now, fortunately, this 97 cannot be divisible by none of either 2 or 3 or 5 or 7. So all numbers are below 9 itself. So one can say the generation of prime numbers by means of this square root method. And as I told, another method, that is Goldbach's conjecture, and then we have Fermat's prime, and then numbers of the form Fn is equal to n square plus 1. Say, for example, I want to generate prime numbers. I am taking Fn is equal to n square plus 1 for all n belongs to capital N. Suppose I am taking n is equal to 1. Then what will happen? F of 1 will become 1 square plus 1, which is 2. That is a prime number. And I want to substitute one more. N is equal to 2. If you take n is equal to 2, it will become 2 square plus 1, which can become 5. So likewise, this is also one of methods to generate a prime number. That is Fn is equal to n square plus 1. And I cannot remember one more. Euler's conjecture is also there. Some number will be there. It will be generating some prime numbers, and then Goldbach's conjecture I told, and then I could hardly remember that prime number theory also. That is, suppose I want to find out number of primes up to 1000. That is equivalent to x by log x. That means 1000 by natural logarithm of 1000. So that is coming around number of primes below 1000 will be around some 530, 540. If you take the approximation of x by log x also, it is coming around nearer to that. But to get more nice approximation, we are taking usually that x by log x minus 1. That is to get more accuracy. So these are all the things to generate prime numbers. So as I told earlier, the beauty of number theory lies in investigation of only prime numbers. And as I told, so far scientists or mathematicians are able to pick up only even perfect numbers. So far, no odd perfect number has been evolved. And one more thing I want to say, as you may be aware, one is Euler's theorem, other one is Fermat theorem. You know, A power P minus 1 is congruent to 1 mod P. And actually it plays a vital role in cryptography. Why we are studying number theory means there is a lot of, stand is there in cryptography, especially division algorithm, Euclidean algorithm, and then congruences, and then Euler's theorem, and then Fermat theorem. All these things are very much useful in cryptography. Nowadays, there is a huge demand for cryptography, and applications of these number theory, especially in congruence theory, is also very much useful, even in RSA algorithm and elliptical cryptography. If we go on talking like this, and the time will not be sufficient for us. Just today, within my knowledge, I could able to deliver orally, but no PPTs are, no slides are being used. So with this, I want to conclude, and I wish all the best for all the participants. And I hope you will succeed in your future endeavors, and you may bring name and fame to this institute also. I once again congratulate Nagesh sir, and then Swami sir, and then the remaining people who are the associates of this organization. Thank you, sir, for giving me this opportunity.
Thank you, sir. Prasad, sir.
Sir.
Prasad.
Sir. Sir, good evening, sir. Srinivas, sir.
Sir, hi, sir. How are you?
Fine, sir. Fine, sir.